A rectangular prism is defined using the coordinate system shown, with A at 2, 0, 0, C at 0, 4, 0, and T at 0, 0, 3. Point M is the center of the planar face OCFT. That means that M would be at 0 to 1.5. And we can see that given here. We want to determine the vector equation for the prism's main diagonal, BT, which is shown on the diagram. Now, following coordinates given, B would be at 2, 4, 0. So, we think about going from B to T. Remember, that's T take away B using the turnaround rule. So that would be 0, 0, 3, take away 2, 4, 0, which is -2, -4, 3. So if we started at B, it would be 2, 4, 0 plus lambda -2, -4, 3. We want to determine the Cartesian equation of the sphere that contains all the vertices of the rectangular prism. So the center of the sphere would need to be in the center of the prism. And that would mean that the center would be at 1, 2, so it's halfway along here, and halfway up, which would be 1.5. Now, what about the radius? Well, the modulus of BT would be the square root of 2 squared plus 4 squared plus 3 squared, from this vector here, which is the square root of 29. That means the radius would be root 29 on 2. Now note, we're after the Cartesian equation. All too often I see students throw a mark away by giving the vector equation when they want the Cartesian. So it's going to be, with the center here, it's going to be x minus 1 squared plus y minus 2 squared plus z take away 1.5 squared is going to be r squared. And r squared is 29 over 4. And so we get x minus 1 squared plus y minus 2 squared plus z take away 1.5 squared is equal to 7.25. Finally, we want to prove using a vector method that line AM does not intersect BT. Now remember, BT has this vector equation. So let's do a vector equation for AM. So AM, turnaround rule, is M minus A. So that's 0 to 1.5, take away 2, 0, 0, gives us -2 to 1.5. And so we could say that this was R equals, start at A, 2, 0, 0, plus mu, -2 to 1.5. Okay, so if they intersect, then using the I components, 2 minus 2 lambda would be equal to 2 minus 2 mu. Now that can only work if lambda is equal to mu. Using the j components, 4 minus 4 lambda is equal to 2 mu, which means that 4 minus 2 mu is equal to, 4 minus 4 mu is equal to 2 mu. Let's tidy that up. That gives me 6 mu equals 4, and that means that mu is 2/3, and therefore lambda is 2/3. And then using the k components, we would have that 3 lambda is equal to 1.5 mu. And that would only work if lambda and mu were both 0. And so with that there, that means that this does not work, and therefore the lines do not intersect.